You know that feeling, right? You write a Python script, you hit run, and it works. It's awesome. But here's the thing. There's a world of difference between code that just works and code that's truly Pythonic. You know, the kind of code that's elegant, super efficient, and actually a pleasure to read. So today, we're going to explore how to make that leap. And our guide for this is Brett Slatkin's fantastic book, Effective Python. Now, don't think of this as some dry textbook. It's more like a collection of hard-won wisdom from a developer who's been in the trenches. We've gone through it and pulled out some of the most powerful ideas you can start using right now. So let me just ask you this straight up. Your code runs. It doesn't crash. It gives you the right answer. That's a success, isn't it? Well, yeah, but is it effective? I mean, is it the kind of code you'd be happy to see again in 6 months? Or would you be scratching your head trying to figure it out? That's the gap we're going to close today. Okay, so how do we do that? We've basically distilled the whole book down into 3 core principles. And I mean it. These will fundamentally change how you think about writing Python. Let's get into it. First up, principle number 1, write for humans. Now, I know what you're thinking. Duh, of course. But it is, without a doubt, the most overlooked rule in programming. We get so focused on making the computer understand that we forget that our code is going to be read by other people or even our future selves way more often than it's written. Every line should be a clear communication, not some kind of weird puzzle. Okay, take a look at this. This is a perfect example. The code on the left, it feels like it was written in C or Java, right? You're manually creating an index. You're using that index to access the list item. It's just clunky. Now, look at the Pythonic way on the right. Bam. The enumerate function does all that heavy lifting for you, handing you the index and the value together. It's not just shorter, it's so much clearer. It literally says what it's doing. For each item and its index, do this. And here's another one that follows that exact same idea. On the left, yeah, it works. You're pulling items out of a tuple one by one, but your brain has to do this little extra step of processing each line. Now on the right, we use tuple unpacking. In one clean, simple line, the intent is perfectly obvious. You're just reducing the mental load, and that really adds up. So writing for humans is the foundation, but the next level is to really embrace the tools Python gives you. And that brings us right to principle 2, use Python's power tools. These are the features that make Python feel like, well, Python. Learning to use them is the absolute fastest way to make your code more idiomatic and a lot more efficient too. All right, let's talk about one of my favorite power tools, generators. So a generator is this special kind of function. It doesn't just run and return one big result at the very end. Instead, it uses the yield keyword to hand you one value at a time. And then it just pauses. It waits for you to ask for the next one. This is a complete game changer when you're dealing with huge amounts of data. And this slide just nails the difference. The function on the left is a total memory hog. It's like trying to carry all your groceries in one giant flimsy paper bag. If you have too much, the whole thing rips and you spill everything. But the generator on the right, it's like a faucet. It gives you one drop of data at a time, exactly when you ask for it. It's lazy, and trust me, in programming, lazy is often absolutely brilliant. Okay, next up is a really common headache, managing resources. You know, like opening a file. You absolutely have to make sure you close it when you're done, no matter what happens, even if your code blows up with an error. The old school way of doing this is with a try finally block. But of course, Python has a much, much better tool for this. The try finally on the left is like manual cleanup. You have to remember to do it, and it's really easy to forget or mess up. The with statement on the right, though, that's like having a self-cleaning kitchen. You just tell it what to do, and it automatically handles all the cleanup for you, guaranteed. It's safer, it's cleaner, and it's just the right way to do it. All right, so we've made our code clear for humans, and we're using Python's awesome tools to be efficient. This all leads us to our third and final principle, build for the future. Because look, great code doesn't just solve the problem you have today. It's designed to be robust and easy to change for all the problems you don't even know you'll have tomorrow. Let's get into error handling. It is so tempting to just return none when something goes wrong, like in the code on the left. But please don't do it. This is a trap. Why? Because none is ambiguous. Does none mean the operation failed? Or is none the actual valid result? It gets even worse if a valid result is 0, which also acts like false. The code on the right is so much better. It raises a specific exception, it fails fast, and it fails loudly, telling you exactly what went wrong and why. No ambiguity.
And when you're handling those exceptions, Python gives you this incredibly powerful 4-part structure. Think of it like a complete contingency plan. First, you try to do something risky. If that fails, you jump to the except block to deal with the problem. But here's the really cool part. If it succeeds, you run the code in the else block. And then, no matter what happened, success or failure, you always run the cleanup code in the finally block. It gives you total control over the flow.
Okay, here is a classic problem that every developer runs into. Let's say you have a class with a simple attribute, like bucket.quota. Easy enough. But down the road, you realize that quota can't just be a simple number anymore. It needs to be calculated based on other things. So how do you make that change without breaking every single piece of code that uses bucket.quota? Well, the answer is just pure Python magic. It's the @property decorator. So on the left, we start with our simple attribute. But later, we realize we need to add logic. So what do? On the right, we turn quota into a method, but we stick that little @property right on top. And here's the trick. To everyone using your class, it still looks and feels exactly like a simple attribute. They can still just access bucket.quota like they always have, but now your new complex logic runs secretly behind the scenes. It's incredible. And the book calls this out specifically because it is such a huge idea. This little decorator lets you future-proof your classes. You can completely change the internal workings of your class, while the outside, the public API that everyone else's code relies on, stays perfectly stable. This is how you build software that can actually grow and evolve without causing a chain reaction of breakages. So when you put all of this together, what does it add up to? It's really about adopting the effective Python mindset. It's not about memorizing a bunch of rules. It's about developing a gut instinct for clarity, for efficiency, and for building things that will last. So let's just recap really quickly. We started with the foundation, write for humans. Use simple tools like enumerate and unpacking to make your code's intent crystal clear. Then we leveled up by using Python's power tools, things like generators and with statements, to write code that's both powerful and idiomatic. And finally, we learned to build for the future by creating robust code with proper exceptions and the magic of @property. And this isn't just some abstract idea. As Simon Willison, the co-creator of Django, puts it, this kind of advice is what helps define what we mean when we talk about Pythonic code. It's the very soul of the language. So, I'm going to leave you with a little challenge. Sometime today, pull up a piece of code you wrote recently. Can you find just one spot to make it a little more effective? Maybe a clunky loop you can clean up with enumerate, or a try finally you can swap out for a clean with statement. Just find that one small, effective change you can make today. I promise you'll already be on your way. Happy coding!